Welcome to the Week 9 lecture for Microprocessors and Robotics. This week we're going to be introducing the for loop. This is an alternative, or it's kind of similar to the if-else commands that we learned last week. So we're going to take that a step up and talk about the for loop. And we're also going to discuss serial printing and serial reading commands. And this is a way that we can communicate with our microcontroller and receive outputs from our microcontroller in the form of text. So last week we covered using an if loop or an if-else loop to check for a particular condition. So in this example here, we're checking to see if the button state is high, or in other words, is the push button being pressed? If it was, then we would turn the LED on, and if it was not, then we would turn the LED off. And so this is a conditional statement. We're checking to see if a condition is present. If it is, we're performing one action. If it's not, we're performing another. So a for loop is kind of similar to our if-else commands in that it's checking for a condition. So a for loop is great if you need to repeat a similar task based on an input, especially if you're counting down or up to something. If you want to perform something a particular number of times, if you'll recall when we were doing our assembly programming, we would loop through, we would set our register value to a number like 3, 4, or 5, and then we would loop through the program that many times. Well, we can do that in C programming too, but it's a little bit different. It's a little bit easier. So for this, we would use a for loop. And so there are 3 main pieces to a for loop. For, if we count, here's our initializing command where we just say for. We have our beginning parentheses, and then we have our initialization. So this is what kicks off the loop. I'm sorry, this is our starting condition of the loop. So this is how we're starting, and then we have a semicolon, and the second section is the condition that needs to be filled to continue. So for our starting state, maybe is a better word, for our starting state or our initialization, check for a condition, and then if that condition is there, afterwards we will increment our value. So let's see what that looks like when we actually plug some code into those sections. So here at the top I have the exact same format that we just looked at, and the example below that is showing what it looks like with variables plugged in. And so we're saying that we're going to start out with an integer. We can declare integers within our for loop, or we can declare them at the beginning of our program. But it's perfectly fine to declare them in the loop in this case. So we're declaring an integer, we're just calling it I, and I recommend using a single letter that won't be confused with anything else. So I, X, Y, and Z, those are all really good variables to use within a for loop. So we're starting out with our integer I, and its starting state is going to be equal to 0. So that's where it's going to start out at. And so now we're saying if I is less than or equal to 255, we're going to go into whatever code follows this bracket. So after this bracket, there would be some more code that would be carried out if the conditions met. So we would carry out all of that code if the conditions fulfilled, and then after we carry out all the code, we're going to perform an action to that variable. So here, the 2 plus signs after the variable just means we're going to add 1 to I. We're going to increment that value by 1. And so this could be used for a fading loop. If we were to turn up our LED, start the brightness at 0, and we wanted to slowly increase the brightness, one way to do that continuously would be to start it out at 0. If it's less than 255, we would turn it on to that value. At the end, increment by 1. And so this loop, this for loop, would keep going until I was incremented to 256, because then it would no longer fulfill the condition. Here's a for loop laid out in a flowchart format to help you understand further what's going on. So we start with our initialization, that's up here. So that's our starting state, and then we check our condition. We see if our condition is fulfilled. So if it's not, we would proceed on with the code. We would just skip the whole loop and come down to whatever was next. But if our condition is true, we're going to go down to our code block. So that would be everything down here, like I said, between the brackets. So this is what's happening. Once everything in our code block is done, we're essentially looping back to the beginning of our for loop. We can see it in our flow chart down here. We're looping back to check if that condition is still present. And so we don't have to increment, we can decrement or do other things to our variables. But we're doing something to our variable, and then we're going to recheck for the condition to see which path we should take. And so this for loop will keep looping and looping until the condition is no longer met. So we have some conditions and some increments or modifications that we can make. And here's a list of the typical ones. So in our example that we looked at, we were checking if I was less than or equal to 255. You can see that's the fourth one down on the condition side. We're usually checking to see if that variable is greater than, if it's going to be less than, equal to, less than or equal or greater than. So here's a list of conditions that we would typically use or that we would typically check for. And then in our incrementing, so in our example, as I mentioned, we would be adding 1 to that variable I each time we went through that for loop, but there's a couple of other things that we can do as well. So we can add 1 if we use 2 plus signs, we can subtract 1 if we just put 2 subtraction signs together, or we can add, subtract, multiply, and divide by specific numbers. And so I just have the number symbol here to represent a number, but you could add any number into that space. So we could have the variable plus 2 if you wanted to increment a little faster, plus 5, etc. You could go the other way with your variable. So instead of checking to see if it's less than or equal to, we could check if it was greater than or equal to, and then we could decrement it down. I think we did that in our looping before in our assembly programming. So there's different ways that you can do these. You can multiply things to increase exponentially, divide, however you need to set up your program. These are some of the common setups that are available to you for conditioning and for incrementing. So I have two different examples of a for loop here. The first one in the top left corner, we start out with our for loop. We are declaring our integer x is going to start out as being equal to 1, and the condition that we are checking is that x is less than or equal to the incoming byte. So whatever that incoming byte is. So let's give that a number. If we say that the incoming byte is 4, and I'll have a little bit more of an output example and a code pictorial later on here. But so our incoming byte, if we set that as equal to be 4, we're going to check if x is less than or equal to that. If this condition is met, we'll go through this loop underneath, and then at the end, we'll increment x by 1. So if I input 4, we meet the condition, right? X is 1, so 1 is less than or equal to 4. We're going to go through these lines of code. And so we haven't gone over our serial print yet, but we will shortly. So essentially what it's going to do is print blink number. It's going to print blink number, and then it's going to print whatever number x is. So x is starting at 1 the first time through. It's going to print blink number 1. And then, of course, our x is going to be incremented at the end. So then x is going to be equal to 2. So we go through the loop again. And you should note that as you circle through this loop the second time, in your declaring section, x is not reset to 1. It is only set one time. The first time you go through the loop, x is set to 1 or whatever you set it to, and it doesn't get reset every time. That would defeat the point of the loop. So we've incremented x. I'll write this up here. So the second time through, our x would be equal to 2. So that meets the condition. 2 is less than or equal to 4. So then we would serial print blink number, and it would print out x. So blink number 2. And then x would be incremented. at the end. So then x would be equal to 3. So it's going to go through the for loop again. 3 is less than or equal to 4, so we would print blink number 3, increment x by 1. It would be 4 now. We would go through the loop. We still meet the condition. It's still less than or equal to 4. So we would print blink number 4. We go through the loop again. Sorry, not before x is incremented. So our new x would be equal to 5. So then we're checking x is less than or equal to 4. Well, now it's not. Our x has been incremented all the way up to 5. So when that happens, then we're going to skip down to whatever the next line of the code would be. So that's how we break the for loop when we stop meeting that condition. All right, so I have another example down here in this larger snapshot. You can see this is part of a more complete code. So we're declaring our pulse width modulation pin label to be an integer based on pin number 10. And so this is an LED in series. This says no setup needed here, but we would probably want to declare this pin as an output. You would want to do that. So then we come down to our void loop, and we have a for loop within this. So this time we're using the integer I. As I said, you can essentially use any label that you want. I recommend using a single character. I is a good one, X, Y, and Z. Those are some simple ones to use. So we're going to start out with the condition I equals 0. If I is less than or equal to 255, we're going to go through the commands in the for loop. Otherwise, within these two brackets, it's the same thing. And then at the end, we're going to increment I by 1. And so you can see that I starts out as 0, and so we're going to do an analog write to the pin, and we're just going to write it to be the value I. So I don't think we've done any analog changes like this in C. I'm trying to remember. I think we did with our brightness setting. We did set the brightness. So we have gone through analog write. So we're analog writing the pin value to be whatever I is. And then we have a very short delay here before we're looping back to the beginning. So you can see I is going to very quickly count up 1, 2, 3, 4, 5, 6, and so on until we get to 255. And what that's going to do is it's going to slowly brighten the LED connected to this pin because we're analog writing this I value. So that's how we can use a for loop in the context of a program. We can use it to control LEDs. In the first example up at the top left, we're using it to control what numbers we're printing. And so there's a lot of different uses for these. Anytime that you find a repetitive action is needed, check and see if a for loop is applicable. If there's some condition that you're checking for, then a for loop is probably a good loop to be using. The next set of commands that we're going to tackle are serial commands. These are used for communicating between the microcontroller, and it can be a computer or another device. We can use a USB typically is how we would communicate with a computer. And by computer, that's usually referring to a keypad input or an output on your screen. So we would have our microcontroller connected in that manner with a USB. There are some applications, so everything that we've done, our microcontroller has been connected to our computer with a USB. There are other things that you can do with microcontrollers. You can run them off of batteries, and in that case, you would not need to be connected to the computer with a USB. You would load your program onto the microcontroller connected, and then you can disconnect it, use batteries to power it, and it can run independently on its own. But for communication, especially through the keypad of your computer and the screen of your computer, we need that USB to connect. There's also other elements that we can connect. There are little number keypads in the project sets at the Tusk campus that you could connect as an input to communicate serially with your microcontroller. You could use an LCD display as an output medium where it could print things out to that. So you have different options, but the most basic is communicating with a computer via USB. And I've kind of answered this question already, but the question that I typically pose to the class is, what are the two main objectives of communication? And so even outside of microcontrollers, if you think about communicating with people, your objectives are typically either to, one, convey information, you're outputting information to somebody or to multiple people. And the second objective is to receive or to gain that information. So when we talk about serial commands, we are accomplishing one or both of those things. We're either outputting information or we are receiving information. And of course, a microcontroller does this in a lot of different ways, right? We declare things as inputs and outputs usually, but serial does this in a very visible format. So serial inputs and outputs will typically be letters and numbers that are being input and output, and they are visible to the user. So before we start to use serial commands in our code or really get into our serial read and write, we need to add a command into our setup, and that is our serial begin command. And so we just have serial.begin, and then we have our baud rate in parentheses. And so this number here, this 9,600 number that I have in parentheses, is just our data communication rate. So we can set this to be slower or faster depending on what we need. But typically we use 9,600. This is a good starting point. You don't really need to go any faster unless you're under special cases. For everything that we're doing in these labs, this number should serve you just fine. And then I also wouldn't recommend going any slower. So 9,600 is a good middle ground of our data transmission rate in bits per second. But you can change this. So after we've declared our serial begin command that kind of sets the tone for all of our other serial commands that we would build into our program. So the first thing that we're going to look at is a serial print command, and there's two different ways to do this. So we said communication is essentially inputs and outputs, inputting and outputting information. And so our serial print, we call it printing data, or it outputs data to the serial port as human readable text. So anything that is a single character would be a byte. Floats have 2 decimal places, and characters and strings we've covered before. And this just has to do with how you're declaring your variables. So there's 2 different ways that we can serial print things. The first is to do a serial print command, and this prints wherever the cursor is at. It will print the output, and it will leave the cursor at the end of the output. Another option to keep things a little bit neater as we're looking at multiple lines of output is the serial.println. And what the ln does is after it prints out whatever data, it moves the cursor down to a new line. So if you're printing multiple lines of code and you don't want it all smushed together on the same line, you can use serial println and it will start a new line after it prints out your data. So you might have noticed after serial print there comes a set of parentheses. So what can we put in those parentheses? There's a couple different things that we can put in there and a couple different ways to note it. So this first snapshot I just have the variable x in parentheses, and so you can put any sort of previously declared variables in these parentheses, and serial print will print whatever the value of that variable is. So in this first example, this is similar to the previous example that we looked at, but now we understand what serial print is doing. So we have a for loop up here. We're starting out with our integer x at 0. We're saying if x is less than 64, go through the loop and then increment it. So part of this loop is serial printing the variable x. And so what this command would do, or this for loop and the serial print command would do, is it would print out the numbers 0 to 63 all in order, right? We would start at 0, X would be incremented by 1, we would go through the loop, then X would be equal to 1, so we would serial print the 1. And so this is a good way if you have a variable that's going to keep changing. Instead of putting in that number, we can just refer to the variable. And so you'll also notice too, this is just a serial print command, not a serial.println command. And so what this means is that all of those numbers 0 through 63 are going to be squished together right beside each other all on one line. If we wanted to have a new line for each number, we would want to use our serial print ln. So in this case, serial print ln is probably a better choice. So you don't just end up with one long number that's 0, 1, 2, 3, 4, 5, 6, and so on, all squished together. The second example I have down here, we can see a little bit more of the code. So in this case, we've made sure to declare our serial print begin. We've opened that serial port communication. And this time we don't have a for loop. We're just using serial print to print some information. And so here's something else that I want to cover is that anything that's a variable, we don't have to do anything special to. We just put that variable in the parentheses. If you want your serial print command to print out specific text that is not already in a variable, we need to put it in quotation marks. So if we don't use quotation marks, the serial print will be looking for a no format variable or a variable called no format. But if we use quotation marks, serial print will just print out the words no format. So this is something to be noticed or to take note of is, are you putting in a variable, in which case you just plop it in between the parentheses, or are you using text? All text needs to go between two quotation marks. So if you're using a mix of text and variables, I would recommend using different serial print lines in a row. So you could serial print no format and then have a second line that said, get a highlighter, that serial printed out a number variable. And if you don't start a new line, they'll print out right next to each other. So that's a good way that you can combine variables and text and print those out if you need to. But typically you'll want a different serial print command for each of those. So we've covered everything about serial printing, about the different variables, putting in text, printing all together on one line, and separating lines. Now we're going to cover how we use serial commands to input information. So the beginning of that is starting an input. And so to do that, we use a serial available condition. So serial available is checking to see if there is anything coming in. Is the keyboard sending any signals to the microcontroller that it should be reading? So it stops the program to check if there is an input. So if there's an input, it will register as a 1. If there is nothing being input, it will register as a 0. And so we couple this with a if loop, or an if check here. So we say if the serial available is greater than 0, then we can go on to the next command. So this is checking, or it's waiting for an input. So if it's 0, there's no input. If it would be 1, it would be greater than 0, and then so it would perform the commands below this. So it's saying that if it's receiving an input, then do X, whatever's after the bracket. So now we'll look at that in the context of what comes after the check. We have the check for information, but how do we input information? So after we check for serial available, if there's any incoming information, we want to store that information into a variable. And we can do this by a couple of different commands. The first is a serial read command. We use this to read an input value, and we can also label the value. So after serial available, we would set our label essentially for the incoming data, or a new variable. So we're calling incoming byte. Whatever somebody types in here will be called incoming byte. And then we're saying equals. This is our serial read command. So nothing goes in these parentheses here. This serial read is just reading in whatever you're typing. So the serial available recognizes if there's an input, and then this serial read command actually stores that input into a variable so you can recall it later or you can access it later. So we can use serial read if we are reading in strictly a number, but in most cases, even if you're inputting a number, it's read as an ASCII text format, and so you'll want to use serial parse. And I would recommend using this for everything that you're programming whenever you need to read a value. Even if you're expecting a number input, this is a good way to make sure that it's in a number form. So serial parse essentially does the same thing, but serial parse looks for an integer. So it looks for the number within an input. So here we have it in the context of a code. So here is our serial available loop. So we're saying if there's an input, that's essentially what this first line is saying. If something is being input, then our incoming byte will be set to whatever that input is, whatever integer is in that input. So if you are expecting text, then you can use serial read. If you're expecting a number, then you would want to use serial parse integer to detect that. Again, the danger if we use serial read to try to look at numbers, when we compare those numbers later on, for example, in a for loop, if we want to check if x is equal to the input value, both of those need to be in integer form. And so what happens is even if you put in a 4, that can be read as a text value. And so the microcontroller can't compare text and an integer. It has to compare two integers. So by using the serial.parseInt command, it will recognize that that number 4 is actually an integer and it stores that value as an integer. So if you're working with numbers, you're expecting a number input, again, use serial.parseInt. If you're expecting text, then you can use serial read. So here we have a full program that is using a reader input and is printing a response. So before our setup, we're declaring incoming byte to be an integer. In our setup, we're setting pin 2 to be an output, which we don't really use in this part of the loop, so that's not as relevant. But then we're starting our serial commands. Before we do any of those, we need to declare serial begin. So this opens a serial port for us and sets the data transmission rate. Again, 9600 is the common rate. That's what you typically want to use. After that, in our setup, we're going to serial print on a new line, or start a new line after this. We're going to say enter a number. So there's a couple different things to notice about this. One is that we're serial printing in the setup instead of the loop. What would happen if we put this down in the loop is that it would print again and again and again. And so you would just get a big long line of the text enter the number and it wouldn't stop printing, right? Because the microcontroller is constantly looping through your void loop code. We only want the text enter a number to come up one time. And so anything that we only need to happen one time, we can put in our void setup. So that's why that's up in the setup. Something else to note is that enter a number is not a variable, it's the text that we want to be printed. And so it is going to have these little quotation marks around it. So it's printing out that exact text. And then this isn't just a serial print command, this is serial print ln. So after this text, it will start a new line. All right, moving on to the next line of our code. I didn't cover this before, but this is important to note when you're using serial parse, is that you'll want to set a timeout for it. I'm not going to cover this in too much detail. It's just giving the parse a certain amount of time to look for an integer. So if it doesn't find an integer in that amount of time, it will go on. And so that command is just serial.set timeout, and then 200 is a standard number that you can drop in there. So anytime you're using the serial parse to read in an integer, you'll want to use your serial.set timeout in your setup. So we've declared serial begin, we've printed the text enter a number, and we've set our parse timeout. Now we can go to our void loop. So here we have an if serial available is greater than 0. So this is waiting for an input. So if there's no input, if serial available is 0, it's not greater than 0, right? Nothing in this loop would happen. So we're essentially waiting for an input to happen before we continue on with our loop. And you could also write this as if serial available is equal to 1. You could do that. That would be just fine. But here we have it as greater than 0. That's how we've chosen to write the equation. So if there is an input, it will go on, it fulfills this condition, and it will continue on to what's in these brackets. So it will set the incoming byte label to whatever is being input. So we're using serial parse to look for an integer, and then we're assigning it that variable incoming byte. So whatever we put in is going to be stored as incoming byte. And then we're going to print, serial print, the words you entered. So we're using parentheses, or I'm sorry, quotation marks. We're using quotation marks because this is text, and we're not starting a new line. We just have serial print. So we're going to say you entered, and then after that we're going to serial print and then start a new line, the incoming byte. So this is where I was talking before about how if you have text and variables that you want to both print out, it's good to split those lines up. That way you can put the text in quotations on one command line, and then you can just put the variable in a second line all on its own. So after it prints out this variable, it's going to start a second line or another line, and then it's going to continue on with the program. So when we run this program, we get the output that you see in this box on the bottom right-hand side. So in our setup, we print out the words enter a number. So it's going to enter a number, and then it's going to wait. It's going to wait for a number to be entered, right? We are waiting for an input before we continue. So if I enter the number 4, it checks what I entered, it parses for that integer, right? And it stores the 4 as the incoming byte variable. Or it's the incoming byte variable. Then it's going to serial print you entered, and then because I did not start a new line, it's going to print right after that on the same line whatever we entered and stored as the incoming byte. So then it's going to print 4. And so this loop continues on. It's not going to prompt me to enter another number because it only does that once because it's in the setup. But if I entered the number 3, it would go through, let me grab a different color here. It would go through this void loop again, right? We're always going through the void loop. So it would be checking for an input, checking for an input. If I input 3, then it would continue to go down through these commands. So then 3 would be the new variable stored. It would serial print you entered, and then it would serial print 3, all in the same line. So I could continue to enter numbers, and it would print out these numbers. So when we are serial reading or serial parsing for an integer, it's looking for an input from your keyboard. And when it is serial printing, it prints out in what we call the serial monitor. So in the next slide, I'll show you how to access that serial monitor so that you can see what your microcontroller is printing. Here is what your monitor or serial communication editor will look like on the online editor. So this is the interface that you'll see. So here you'll see I have the code plugged in into my sketch that we just saw in the PowerPoint. And then over here on the left, I have it highlighted already. If you look all the way on the left where it says monitor, you'll want to open that either before or right after you download your code to your Arduino board. So go ahead and open that. And then you'll see here in this screenshot, it's already prompting us to enter a number, which it should do according to the code. And so the way that we can communicate serially with our Arduino board is that you would click in this window up here. This is your communication window. So here we're reading, and up here we can write. So up there in that top window, this is where you will enter a number. So if we were to enter the number 9, and then you would hit send to send your entry to your microcontroller. And so then it would receive that number, and according to the code, it would print out you entered 9. And we would see that printout come over here in the readout portion of our monitor interface. So again, you just want to make sure that you have your monitor opened either right before you download your code to your board or right after, and it just stays open on the left side, and you can see what's happening with your code if it's prompting you for any inputs, and then you can of course put in an input as you're prompted to do so. In your Lab 7 assignment for the week. So the objective here is of course to use your new serial commands to communicate between your controller and your computer. And we're going to use a for loop for some of these communications. So in part 1, you're going to blink an LED 10 times with a for loop. And my little hint to you here, of course you can refer back to this lecture, but the hint within your lab is the setup of a for loop. So this notes that in your for loop, you'll need an initialization, you'll need a condition, then you'll need an increment of some sort or a modifier. And so you'll write a program to blink an LED 10 times in a row using a simple for loop. So this one should be pretty easy. I would recommend blinking the integrated LED first. I think I talked about this last week, so it's always good to use the integrated components if you can first to check that your code works as a verification, and then you can connect your external components and make sure those are connected right. So if it works right the first time using the integrated LED and it's not working when you have an external LED connected through your breadboard, then you know something is wrong with your LED circuit. So I would recommend doing that, but either way, you'll be setting up an external LED off to your board that you'll be blinking 10 times with a for loop. I don't need a video of that, I just need the code. And then for part 2, you'll be editing your program to print the message, blink number, and then whatever number blink that you're on. And so this just means that after each blink or before each time your LED blinks, it will print out what blink number it is on out of 10. And so again, I'm giving you a hint. It's easiest to do this with 2 separate print commands, one for the text, the blink number text output, and then a separate print command for the variable that you're outputting. And then as part of this, if you would take a screenshot or a snippet of what your serial monitor looks like at the end of this program. So the end of this program, we should be able to see blink number 1, blink number 2, blink number 3, and so on until we get to 10. So I don't need a video of the LED blinking, I just need a quick screenshot of your serial monitor showing that you were able to get it to print out that message. The second part, the second section of part 2, part B, is adding a prompt using your serial read and available commands to ask the user how many times the LED should blink. So before, we were automatically having it blink 10 times, then we were adding in a message, printing what number blink it was on. Now you're going to add a prompt to ask the user how many times the LED should blink. So if you want it to blink 3 times, somebody should be able to type in the number 3 and it will blink that many times. Somebody should be able to type in the number 8 and it will blink that many times. And in conjunction, it should still keep printing out what number blink that it's on, like in the previous program. Also, please note here that you should add a prompt to the user. So don't have them assume or don't make it so that somebody using this would have to assume that they needed to print or input a number, add a prompt or a serial print command that tells them enter a number, or use some form of text to tell them that they are entering a number to make the LED blink. So that message should be printed so that the user knows what they're doing. So that's where the prompt comes in. Make sure you include that. And then I've also included a hint for you on this one to change the declared integer to only empty labels that can be set to equal the user input. So this is just a hint for when you're setting up your variables and you're working with your inputs. Keep this in mind. And then as for A in part 2, for B in part 2, I will also need a screenshot of what your serial monitor looks like at the end of the program. It doesn't matter what number you put into it, as long as you have that prompt, the user is putting in a number and it's printing out that blink number message. I will say do not put in the number 10 in response to this prompt, because then I won't be able to differentiate. So input in any other blink number except for 10. So if you can manage all those, that's great. I think that covers Lab 7, and then it's not shown here, but as usual, your last question is talking about the objectives and the concepts used. So just to touch on that a little bit more, because I've received a couple of short answers from people, so I want to make sure that the expectations for that section is clear. For the objectives, for the outcomes, you should be talking about what happened in your lab. If you had to troubleshoot anything, that's the spot to kind of talk about that. You know, my external LED wasn't connected right, so I had to troubleshoot what was wrong. I found out that it wasn't connected to the ground. So that would be something that you learned in this lab. And then course concepts would just be a couple sentences about what we learned this week. So you could talk about the for loop, you could talk about serial commands, using things in conjunction. You don't have to have all of the information from this lecture in there, right? I don't need paragraphs and paragraphs, but just a couple quick sentences on each of those. A couple sentences on what happened when you did this lab, and some sentences on what were the main concepts. Tell me about those. So that's my expectations for that last question. That's a little bit more of an essay question. Okay, so I noted a couple weeks ago that we were going to be starting our projects soon, and to keep that in mind as you were working on your labs and working with your Arduino boards and exploring their capabilities. So I wanted to go over just a quick refresh of some of our brainstorming techniques that you can use, because that's what you'll be doing this week. You will be brainstorming potential projects. So as I mentioned, I covered that a few weeks ago, so if you want the in-depth explanation, see that lecture, but here I'll just go over these real quick. So you will be able to use, or you're free to use, the mind map or the cluster method, where you start with a central idea and you branch modifications off of that. So we start with, for example, cooling and AC. What could we explore from there? Heat absorbing proteins. This one's a little bit more geared for some other disciplines, and then of course off that we can explore heat shock, and so you can really branch off. So you can start with your idea. If you really like the concept of using push buttons, you could say, okay, what can I do with push buttons? And so you would branch off, and one branch could be using them to control LEDs. Another branch, you could use a push button to control another sensor, and things like that. And so you can use a mind map as one of your brainstorming techniques. Another more simpler method for brainstorming is to generate a whole list of ideas, group together which ideas are similar, and then you're essentially picking out kind of the top idea out of each group. This allows you to not stop yourself from thinking of projects. So instead of coming up with one and then thinking of another and then mentally stopping yourself and and saying, no, I've already thought of something like that. That's too similar. You just write everything down, and then you can group together the similar things. And then your review period is essentially a summary. It's either kind of what's the best project or the most appealing project out of group A. Okay, that kind of goes to the finals. What's the most appealing or kind of an all-encompassing project from group B of my ideas? Okay. And so you would probably have maybe between 3 and, I don't know, possibly 10 groups of ideas, depending on how many you generated. So again, you're just letting your mind wander a little bit, writing down anything that comes to mind, and then grouping things that are very, very similar so that maybe you can stack those ideas up and build a project with more complexity, or you can pick and choose what seems like the best out of that particular group. Another brainstorming technique you can use is storyboarding, and here you're essentially drawing out how your idea would operate. So everyone who is very visual, this could be a good way to get that out. What does that look like? If you really liked using the flowcharts and they helped your mind step through a process, storyboarding might be a good brainstorming technique for you. This one's a little bit different. But it's certainly worth at least giving it a shot. So what does your project look like? What happens first? What's in scene 1? And then what happens in scene 2? So what's the next step of your project? And this kind of lets you step through breaking down what your project potentially looks like as it runs, what are all the inputs and outputs, or the main inputs and outputs. You don't have to get down into the nitty-gritty details, but storyboarding can help you step through and better visualize what might happen in your project. Then lastly, we have our wish lists. So when you're brainstorming using the wish list method, you think of a lofty goal. If you had all the time and resources on your hands, what could you accomplish with an Arduino board, or what would you want to accomplish? And you would start out with that lofty goal or with a couple of those, and then ask yourself a couple questions to pare them down to something that's more manageable to fit within the scope of this project. So now that you have this giant goal to potentially accomplish, ask yourself, what makes it so impossible? What are the barriers to getting that done? Is that time? Is that resources? Is that having enough people or resources, components that you might need? So identify those limiting factors, then ask yourself, how can the idea be scaled down to something that's a little bit more manageable? So if you think your initial idea will need 10 weeks and we only have about 5 left in the semester, can you cut half of the content? Can you kind of strip away some of the frills and be left with the bones of the idea to work on there? Or if you need a whole host of really complex components, can you swap them in for some more accessible components, things like that. So you're figuring out how to take your wish list idea up from 100 down to, maybe a 10 so that it's more manageable in the 5 weeks that we have left. And then you'll ask yourself, what are the real features? What's the real basis of the idea in your wish that you can integrate? So this week, in addition to your lab assignment, you're going to go through at least one of these brainstorming techniques that I just outlined. Or if you have a different brainstorming technique that you've found, feel free to go through that as well. There's no specific way that you have to go through this. I just recommend using at least one of the techniques as kind of a structured brainstorming method to help you keep from hitting a wall and give yourself the largest amount of potential project opportunities, because then you have a better chance of picking a successful project, I think. So go through at least one of the brainstorming techniques, either that I've listed or one that you've found. I would recommend going through at least 2. That way you can look at it from different angles. So like I said, the storyline technique's a little bit different. So you might want to start with a mind map and see where you get, and then flesh out 1 or 2 of those ideas in the storyline technique. So you can mix and match techniques to get the most out of them. And then what I want you to do is post what you think are your top 2 project ideas with a brief explanation as a discussion post. So your explanation should be enough that I can understand what you're trying to do with the project and that your classmates can also understand what you're trying to accomplish and what's potentially involved in the project. Because next week you will be giving feedback to each other on your potential project ideas. So keep in mind at this point you're not selecting your final project yet. You're just coming up with your top 2 ideas. So don't get too attached to either one at this point. And then next week I'll divide you into smaller groups. So groups of probably about 3 or 4 students per group. And then you can just provide input into each other's projects. If you need any support or some input on your project besides using me as a resource, you can also rely on that smaller core group. So I'll be trying to match up people that most likely have similar projects. And we'll see how that plays out. But that way, if we have a couple people who are working on similar projects, if somebody has run into a pitfall, you might be able to warn the other students, or if somebody else comes across it, you can help them figure it out. And so your projects are not group projects, but there's a little bit of a group component there to where you are still working with other students for input and feedback concerning these projects.